Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking about another type of quadrilateral. Now, unlike the ones we've looked at, so we've talked about the general sense quadrilaterals, just any four-sided figure. Then we talked about parallelogram, which by definition opposite sides of parallel. And then we talked about the next two parts here, where a rectangle and a rhombus, where a rectangle, really the thing that made it different was that it has four right angles, and a rhombus, which has four equal sides. Both of those properties then combine to form a square, which, all four sides are equal, right angles, so it had all the properties. But there's more than that, than these types of quadrilaterals, but they do belong uh, in their own category. The one we're going to look at today is a trapezoid. And a trapezoid, by definition, all it just needs to have is exactly one pair of parallel sides. And that's it. So let's look at notes here. So for a non-isosceles trapezoid, just any trapezoid in general, by definition, only one pair of opposite sides are parallel. And because of the nature of the lines being parallel, we know that the consecutive angles between those parallel lines are supplementary. There's another special type of trapezoid called an isosceles trapezoid. Think of an isosceles triangle where not only are two sides the same, but their base angles are the same. It's the same concept as this here. The non-parallel sides, or what we call the legs, are congruent. The diagonals, as you can see by these dotted lines, are congruent. The base angles, so when we talk about base angles, just like an isosceles triangle, we're talking about this angle right here is congruent to that angle, and this angle here is congruent to that angle. And what's kind of cool is that these opposite angles here, so the ones I'm circling, they're supplementary. And there's a proof to understand why, and maybe we will get to that. So let's look at a couple examples dealing with these properties. So for number one here. Now, first things first, like I said, it is always very important to know, but through labeling, what you have here. Is this a non-isosceles or isosceles trapezoid? You would be correct in saying it's a non-isosceles trapezoid, and the reason why we know that is because it doesn't have the tick marks on the legs. So here, based off of what we have, to find angle K, remember these two angles here are supplementary along the non-parallel lines. So to find angle K, you do 180 minus 51, which gives me 129. And then to find angle M, same concept except with the 87. So 180 minus 87, which gives me 93 degrees. How about number two? Well, number two is the same concept. This is a non-isosceles trapezoid, so I would have to, find out what angles C and D are by taking 180 minus its consecutive angle. So to find angle C, I do 180 minus 31, which gives me 149. Then I do the same thing for angle D, 180 minus 62, which gives me 118. All right, how about in terms of an algebra here? Well, again, we have non-isosceles trapezoids, so what do we know about the relationship between these two angles? You'd be correct in saying that they're supplementary. So I take 54 plus 8x plus 6 and set it equal to 180 and solve for x. So it's like I got 60 plus 8x equals 180. 8x equals 120. So x is going to be equal to 415. And that's the same concept for number 4, except that I want you to find angle R. So once you find x, you just plug it in. All right, let's move on to the next one here. Okay, number 5. So this problem here is just basically saying it's an isosceles trapezoid. So if it's an isosceles trapezoid, what does that mean? DG, which is this side right here, has to be congruent to what? Has to be congruent to EF because it's one of the legs. Likewise, remember an isosceles trapezoid, The diagonals are congruent. So if we have DF, that means GE must be congruent. And then number 6 is just talking about the angle. So if I have angle T, remember, it has to be congruent to angle U because that's considered base angles, the angles along the parallel lines. And then angle V has to be congruent to angle W. All right, so let's actually look at an example with an angle measure. So number 7, we know it's an isosceles trapezoid because we got only one set of parallel lines and we got the legs congruent. So what does that mean about angle Q? Well, angle Q is the same as angle P, so it must be 112. And then we also know R and S have to be the same because they're along the same parallel line, they're the base angles. And to find that, it shares the property of trapezoids. We take 180 minus 112, which gives me 68 degrees for both. All right, and it's the same concept for number 8 here. So we'll skip that and move right along here. I'm just trying to see what problems we got here. Okay. So for number 9, so it says it's an isosceles trapezoid. So you got all those properties there. They gave you MP. Oh, it's loading. So they gave you MP is some sort of measurement. Let me refresh this here. I apologize if in the video you can hear some music playing in the background. It's my neighbors behind us. So MP is 16x minus 13. NO is 9x plus 8. And they gave you PN is 5y plus 19. And MO is 12y minus 37. And it says find x and y. And you might be thinking, oh crap, there's two variables. You gotta do whole systems here. Not necessarily. Because MP is congruent to which side? That's right, NO. And lo and behold, they're the same variables. So I could take 16x minus 13 and set it equal to 9x plus 8 and solve for x. Let's see, 7x equals 21, so x equals 3. And then likewise, they gave you Pn. Well, that's congruent to MO. Same variables, solve for them. 5y plus 19 equals 12y minus 37. Looks like I'm going to have here 56 equals 7y. So y is going to equal 8. See, that wasn't so bad. Let's look at number 10. It says figure ABCD is an isosceles trapezoid. All right. So, what does that mean here? What do we know about these two angles that they gave us here? You're right. These are the base angles, so therefore they are congruent. So we would take 2x plus 27 equals 5x minus 12 and solve for x. So we get, looks like 39 equals 3x, so x equals 13. Well, how does that help us to find these angles here? Well, I can't figure out what A and B are right now, but I can figure out what C and D are. And I know if I plug into D or C, the other's the same. So I'll just plug into angle D here. So that I have 2 times 13 plus 27. Well, 2 times 13 is 26. 26 plus 27 equals 53. Which means that's the same for angle C. A and B we know are the same. And to find that, property of trapezoid. 180 minus 53 gives me 127. All right. How about number 11? Well, with number 11, again, this is an isosceles trapezoid. But what do we know about these two angles? Well, they're not the same. They follow the property of a regular trapezoid, which is they're supplementary. So take 4x plus 17 plus 10x minus 33 and set it equal to 180. And 4 plus 10, 14x. 17 plus 70 minus 33 should be minus 16 equals 180. 14x equals 196. And then divide each side by 14, and I would get, let me get my calculator out here. 196 divided by 14. 14, though. Okay. So now, well, I can plug into one. Then let me plug into angle M to start. So I have 4 times 14 plus 17, and that would equal 73. Well, what else is 73 here? That's right, it's angle L. Now, I could plug 17 in for J, right? 10 times 17 minus 33. But what should it be? You'd be correct as saying that it should be 47. 147. No, sorry, 107. There you go. So it should be 107. And the reason why I know it is that is because I could just do 180 minus 73. That gets me 107. And then by definition, too, angle K has to be that too. Alright, so again, just like all of these, you're just using the properties here to determine how to set up. Let's do one more here. Yeah, one more. 12. So what's the relationship between these two angles? Remember, the relationship between these two angles, they're not the same, but they are supplementary, right? Think back to right here. Opposite angles are supplementary in a isosceles trapezoid. So with that here, we would just do 10x plus 5 plus 6x minus 1 equals 180. Solve for x. 16x plus 4 equals 180. 16x equals 176. And x is going to give me 176 divided by 16. 11. So I can plug it into angle W here. 10 times 11 plus 5. That's 115. Which we know angle X is also 115. Angle Y is going to be 6 times 11 minus 1, which gives me 65, which means angle Z is 65. All right. And that, ladies and gentlemen, is how you take care of some of the properties. We're going to have to do more in another video here of trapezoids and isosceles trapezoids. So for your homework, what I would like you to do, what I would like to happen is this page to reload. Okay. So what I would like you to do is I would like you to do for homework, trying to see here, 1 through 10. Okay, just do 1 through 10 for homework. And yeah, remember, as always, if you ever have any questions or concerns,